Hey y'all, we are Memphis Community University and we're back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today we're going to be doing our most important lesson of our limit unit. Basically, we're going to try to learn how to evaluate as many limits as possible. And what's going to be required of us will be certain algebraic skills. These include expanding things, factoring things, and working with square roots, absolute value, and fractions. So keep in mind that we're not going to be doing any calculus today. We're not going to use calculus tools like evaluating limits as definition of derivative or L'Hopital's rule because technically we don't know what derivatives are yet. We only know what limits are. But again, hopefully this video will provide you with a lot of different examples so that you're confident when you evaluate limits for yourself. So let's get started. First off, I'm going to write out a few steps that might not be the most useful steps in the world, but I like to write them out just to have a general gauge of what we're trying to do here. So what we're doing is we're evaluating limits algebraically. Evaluating limits algebraically. So what are the steps here? So the first step is always just plug in the number that you're going towards. So plug in whatever number you're going towards, x going towards a. So if it says limit as x goes to 2, we're going to take that 2 and just plug into the function. And what's going to happen in a few cases that you're just going to get a number like 7 or 3 or 0. And if that happens, that's the best case scenario because you're already done. So in that case, if we get a number, that will be the answer. You can imagine that the process isn't that easy every single time, so this will only happen in rare cases. Basically, we'll be going to a function whose continuous at this number x equals a. We talked about continuity in a previous video. But if a function is continuous, to evaluate that, you just plug in the number. Unfortunately, what's going to happen in most scenarios is we'll get step 2. We won't get a number, but we'll get something like 0 over 0. 0 over 0 is what is called an indeterminate form. Basically, you don't know what 0 over 0 is because what is 0 over 0? Is it 1? Is it 0? Does it not exist because you're dividing by 0? It's an indeterminate form. So what we're going to do is we're going to have to do what I call follow your heart. So this is going to be the follow your heart step. And follow your heart is sort of a cheeky way of saying don't use your brain. Just look at the problem, look at what the problem is giving to you and just do your first instinct. So it should be pretty natural in what we are going to do. So for example, some things that are examples of following your heart is to factor something if something looks like it can be factored. So we're going to factor things. We might expand things if things look like they should be expanded. And finally, we might multiply by conjugates for square roots, as we'll see in one of the examples. So multiplying by conjugates with square roots. Then we might have fractions that might be needed to be added or subtracted together. So we're going to add and subtract fractions together. And finally, we're going to work with absolute value, probably the hardest questions at the end of the video. So we're going to get rid of absolute value by using it as a piecewise function. But again, that's later on. Get rid of absolute value bars if that's the case. So those are going to be our follow your heart steps. Again, it's just going to be what do you do as the most obvious thing. Oh, this looks like it needs to be expanded. I'm going to expand it. Oh, I'm dealing with square roots, I'm going to immediately multiply by conjugates. I'm not going to use my brain to think about whether that's the right step because I know it's the right step. Finally, what happens is that once you follow your heart, you should be rewarded quite instantly because good things will happen in the question. Mainly that things will cancel out basically so that you're going to get something simpler. So the third step after you follow your chart is just to plug in the number again into your simplified thing and you'll probably get a number and that'll be the answer. So that's step 3. Step 3 will be plug in the number. Sorry about that 3 in that circle. But you're going to plug in the number again once you followed your heart so that everything is simple. And you should get a number and that will be your answer. So remember that the answers to all limit questions are just numbers. So if you're lucky in the first step, you'll already get a number. But if you're not lucky, it's going to be okay. What we're going to do is we're going to follow your heart by doing a natural sort of algebraic skill. And then we're going to plug in the number again once we cancel out stuff. And we should get a number and that will be our answer. So that's the process. Plug in a number. See if you get 0 over 0. If you do get 0 over 0, do something. After you do something, good things should happen, and then finally plug in that number, you should get a number now. So let's try to do some examples. So the first example is sort of the easy, beautiful case that won't happen very often, but sometimes we get lucky. So the first one I'm going to do is the limit as x goes to 2 of x plus 1, x squared minus 3x plus 7. So if you take this limit right here, and let's see what happens when we plug in the number. So again, just take your number, whatever you're going towards, and just plug it into the function. So it looks like when we plug in this, we'll get 3 in the bottom because it's 2 plus 1. On the top, it'll be 4 minus 12 plus 7, I believe, because it's 2 squared, 3 times 2. That's actually wrong. It should be 6. Sometimes plugging in a number is not the easiest step in the world, I guess. 4 minus 6 plus 7. Looks like we're going to get 5/3 here. 1 plus 4 and divided by 3. So it looks like we again have the best case scenario. We just have 5/3. So we're just done with the question. So again, just plug in the number at the very beginning. If you get a nice little 5/3, that's the answer. If you get 0, that's the answer. If you get pi, that's the answer. Again, just plug in the function and just see what you get. Unfortunately, this won't happen in maybe 95% of the cases because you're going to get 0 over 0. So let's do our first 0 over 0 question, and you'll see that it's not as bad as it might seem. So let's erase this. So the next thing to do is to try to do this limit. So let's do the limit as x goes to 3, x minus 3, we'll have x squared minus 5x, and then I think I want plus 6, I believe, because that will make it 9 minus 15 plus 6. Yes. So again, same thing. It looks like the same sort of question, so we do the same first step. Just like normal, we're going to plug in 3 and see what we get. And we're going to hope and pray to get just a number, but we might not, and then we'll deal with that later. So when you plug in 3 here, it looks like you're going to get 0 on the bottom, 3 minus 3. Then you get 9 minus 15 plus 6. 9 minus 15 plus 6, unfortunately, is 0. So we do get the dreaded 0 over 0. So this is what's going to happen in the majority of the cases, but we don't need to panic because all we're going to do is follow our heart, and our hearts are strong. So basically, look at this question and just tell me, what do you think is the most obvious thing to do? There's not much this question is offering me. I just see something that can be factored, so I'm immediately going to try to factor it, and that's the only thing I can do. So it's going to be the limit as x goes to 3, and we're going to factor this bad boy in the top. Again, we haven't factored maybe in a while, since maybe your Algebra 1 days, but it's nice to greet old friends and welcome them back. What's this factoring? Looks like it's x minus 3, I believe. Then it'll be x minus 2, and then it'll be x minus 3 on the bottom. And this is the correct factoring, I think, because minus 3 times minus 2 is 6, and minus 3x minus 2x is minus 5x. So this is the correct factor form, and notice that once we followed our heart, which was factoring, something immediately good happens. And what is that in this case? Well, the x minus 3's immediately cancel, so now we can just plug in the number again, and notice that we'll just get a number. So we can write out that step. You don't have to write this out, you can probably just plug in the number right there. But I'll write this step for you guys. It's going to be plug in 3 here, so notice that you're just going to get the nice number of 1, 3 minus 2. So again, this is how the process will always work. You're going to plug in a number and you'll probably get 0 over 0. Once you get 0 over 0, look at the question, listen to it carefully, see what it wants you to do. In this case, it's factor. We factored, and if you do the algebraic step correctly, you should be rewarded karmically immediately, which in this case, the x minus 3 is canceled, and then we're left with just this x minus 2. At the very end, just don't forget to plug in the number again to just finally get the answer. When you plug in the answer again, you shouldn't get 0 over 0, you should just get a number, and that'll be the answer. So this was a nice little factoring guide. Let's do the opposite, which is an expand question. So I'm going to erase this. I'm going to erase this. So sometimes we don't use the letter X. As you see in our next video, H will feature prominently, so we're going to use H instead, as we talk about derivatives in our next video, which hopefully you will join us when we do that one. So we have H on the bottom here, nice long fraction bar. Then we're going to have H plus 4, and then we're going to subtract off 16. So this is my next question. So again, first step, you do need to check this step because potentially you might get lucky and you don't have to do any more work. But we are going to plug in the number here. It looks like we're plugging in 0 and just verify what we get. So in the denominator, it looks like we're going to get 0. So now we only have to do the numerator, if I can write a nice 0. So now we have to do the numerator. So when you plug in 0 into the numerator, notice that you'll get 4 squared minus 16. So this is 0 over 0. We are in business. This is what we are expecting. So again, in the last question, there was something that looked factorable, so we factored it. Here, our heart tells us, well, there's this thing that can be expanded and FOILed out, so we might as well try to do that. And let's see what happens. So in this case, it'll be the limit as h goes to 0, and we're just going to try to FOIL this. So if you want, you can write this as h plus 4 squared over h, and then let's try to FOIL it. So it's going to be the limit as h goes to 0, h on the bottom still, this 16 on the end doesn't change, but it looks like it's just a factor that you're pretty used to FOILing out. H squared plus 8h, because it's 4h and 4h, plus 16. So it's h squared plus 8h plus 16. And notice again, right when we do this step, good things are going to be happening. Because notice that things will cancel basically. So when you have 16 minus 16, that of course is 0. So I'm not going to complain about that. So we're going to be left with the limit as h goes to 0 over h squared plus 8h over h. And again, if you wanted to, you could plug in 0 and notice you will get 0 over 0. So again, you have to do something. But we can also just eyeball this and notice that we can simplify things further. Hopefully you know your fraction rules, but if you have a common factor in every single part of the fraction, you're allowed to divide by it. You're allowed to cancel out h's. This is not butchering, of course. For example, if this term was h squared plus 8 over h, we would not be able to cancel out these h's because this one wouldn't have an h. But because this one does have an h, in this scenario, we can cancel things out. So hopefully that wasn't too confusing. I can divide by h, I can divide by h. Obviously, if you have an h squared and you divide by h, you just are left with 1h. So it looks like all we're left with is the limit as h goes to 0. Hopefully you can read this, h plus 8. So when you plug in 0, looks like we're going to get a final answer. We can write in the corner of just 8. So again, it's the same process that we did in the previous case. We got 0 over 0, but instead of factoring, we expanded. Expanding brought us great results. 16 minus 16, boom, 0, h, boom, crossing things out. We get h plus 8. At the very end, we plugged in this number, and it wasn't too bad. 0 plus 8 is just 8. And that's all it is. So let's do some harder questions. Expanding and factoring are usually the easier questions because you're used to expanding and factoring. Let's try to deal with square roots and fractions. So let me erase this real quick. So I'm going to erase this. And I'm going to erase. And we're going to try to do another one. So the next one I'm going to do is the limit as x goes to 49 square root of x minus 7 over x minus 49. So this is a probably pretty common square root question. Again, first instinct is just to plug in the number and see what happens. Notice that in this case, when you plug in 49, you're going to get 0 over 0 because the square root of 49 is 7. So you're going to get 7 minus 7 over 49 minus 49. So that's going to give you 0 over 0. So this is the case, of course, that we have to do something. In the previous two questions, it was more obvious what to do. If you looked at this for the first time, you might not know what to do because it's very sort of counterintuitive. But once you do a lot of these square root questions, you'll know how to follow your heart. Basically, what you're going to do every single time is you're going to multiply by the conjugate of the numerator so that you can get rid of the square roots in the numerator. This is really similar to the complex conjugate process in Algebra 2, for example. So in this case, we're going to take the limit. And we're going to write x minus 7 over x minus 49. And we're going to multiply by the conjugate. And what is the conjugate? Basically, it'll be the square root of x. And if it's minus 7, you're going to multiply by square root of x plus 7. And if it was square root of x plus 7, you're going to multiply by square root of x minus 7. So the conjugate is this term and this term where you switch the negative and the positive. So in this case, again, you can't multiply by things arbitrarily. So that's why you have to multiply by the conjugate over the conjugate so that this is algebraically sound because you're multiplying by 1. So in this case, let's deal with the numerator because that's the point of all this madness. So notice that we're doing this so that, again, we're getting rid of the square roots in the numerator. So it's going to be difference of squared, square root of x times square root of x, that's just x. Then you have minus 7 root x plus 7 root x, that's going to cancel out. So it looks like we're going to be x minus 49 will be the numerator. what I would recommend you do is to definitely do not try to FOIL this out, because notice, again, right when we got rid of the square root in the numerator, we will have good things happening because this x minus 49 will cancel out with this x minus 49. So we're going to be left with x minus 49 times square root of x plus 7. Let's wrap these in parentheses. Again, if you're doing the algebraic step correctly, good things will happen. This will cancel out with this, and now we can just plug in the number. So we're going to have the limit as x goes to 49, then it'll be 1 over the square root of x plus 7. Square root of 49 is still 7, so it looks like we have 1 over 7 plus 7. So this final answer is 1 over 14. So while this question was a bit harder, once we discovered what the algebraic step was that we should do, it became the same sort of thing. We got 0 over 0, we did the algebraic step, good things canceled out after we did the algebraic step correctly, which in this case is multiplying by conjugates. Finally, we plugged in the number, and that's the answer. So this is how the question works mainly every single time. 0 over 0, algebraic step, if it's square roots, now you know that you need to multiply by conjugates. This is how you multiply by conjugates. Once you do it correctly, you cancel things out and you plug in the number. So let's do one more of these sort of normal questions, and then we'll deal with absolute value later. So the last normal question I'm going to do is I'm going to do something that involves fractions. Fractions can be intimidating, but we have dealt with fractions in the past, so hopefully we will be able to solve this question. So I'm going to go back to the h's, and I'm going to have h goes to 0. I'm going to have 1 over 5 plus h, and finally 1 over 5th, and then it's going to be h on the bottom. So why don't you pause the video and try this one for yourself, just to see what happens. You will get 0 over 0. We can do that step together because you're going to get 1/5 minus 1/5. That's 0. And then you plug in h to go into 0 on the bottom. You'll get 0. So we do get 0 over 0. So what I would recommend you to do is just try to do the something to follow your heart step by yourself. I'm not going to watch your work so that you don't feel pressured. And 3, 2, 1. We're going to unpause the video and then we're going to start and work together. 3, 2, 1. Let's go. Let's go. So again, what we need to do is we need to do some sort of algebraic step. So the algebraic step, I argue, are we have fractions that can be combined using subtraction. So what we're going to do is we're just going to try to combine those fractions. So in this case, how do you combine fractions? How do you combine fractions in every single case? What you do is you want to have a common denominator and then you combine the fractions. So what's the easiest common denominator right now? Well, it looks like we're just going to multiply 5 by 5 by this one, and then 5 plus h by 5 plus h for this one, the common denominator being the product of the original denominators. So in this case, it's going to be 1 over 5 plus h times 5 over 5. So again, I'm multiplying this one by this denominator, and then I'm going to multiply this one by this denominator. So it's going to be minus 1 over 5 times 5 plus h over 5 plus h. Keep in mind that we're still divided by h, so now we have fractions within fractions, but it shouldn't be too crazy. So again, the point of this was to have common denominator, so let's rewrite this. So we have h on the bottom, a nice big h, and then we have 5 over 5 plus h, that was our common denominator, and it looks like we have 5 minus 5 plus h. Be careful in this question, when you multiply by these common denominators and you're subtracting, notice that this negative will go for each of the 5 plus h, so I do want to be careful with parentheses. So let's see what happens. So we're going to have limit as h goes to 0. Then, looks like in the numerator, we're going to have 5 minus h. Again, you have to distribute this negative, so these 5's cancel. So it looks like we're just left with negative h over 5 times 5 plus h over h. So again, good things happen immediately because all these 5's canceled, and now we are left with this. Hopefully you know how fractions work. When you're dividing by a fraction, when you have fractions within fractions, what you're doing is you're multiplying by the reciprocal of that fraction. So in this case, when we simplify this, after that good step of combining these fractions and we cancel out the 5's, there's still things left to be canceled out. So in this case, we're going to take negative h over 5 times 5 plus h, and we're dividing by just h. That's the same thing as multiplying by 1 over h. So notice that when we multiply by 1 over h, these h's cancel. You could have canceled the h's in this step, for example. So now, looks like everything is good to go because we will get a number in the end. Looks like we have limit as x, as not x, but h, goes to 0 of 1 over 5 times 5 plus h. We certainly are not going to forget this negative because when these h's canceled, the negative didn't cancel. It looks like when we plug in 0, we will get a number. When we plug in 0, it'll be 5 plus h, which is 5 plus 0, that's 5. 5 times 5 is 25. So it looks like our final answer is negative 1 over 25. And that is our answer. So again, even if it was harder than the square root question potentially, the expanding, the factoring, because we have fractions, we still did what our heart told us to do. That was combine these fractions with a common denominator. Once we did that, the 5's canceled. If we were careful with the negative, the h's canceled as well, and we were just left with a number. Once we plugged it in, it was negative 1 over 25. So again, hopefully you know the general strategy by now. Recognize you get 0 over 0. Do something algebraically. In this case, it was combine fractions together using a common denominator. Then things will start canceling out pretty nicely. And then finally, you're going to plug in the number. But we do have to talk about a harder concept right now, and that's going to be absolute value. So again, absolute value is one of our old enemies, potentially from algebra. But the main thing about absolute value is we always want to picture it as a piecewise function so that we can think of it absolute value sort of separately so we can get rid of the absolute value bars. Keep in mind that we have a future video focused directly on absolute value once we introduce derivatives. That video is called Absolute Value and Limits and Derivatives or something like that, or limit and derivative questions involving absolute value. Be sure to check that out in our playlist if you want more practice with absolute value, because in this video we're just going to touch upon it. But again, let's try to do some of these absolute value questions. So limit as absolute value. So still remember the strategy of just plugging in the number and you might get an answer. So in this, sometimes when you have absolute value, it is pretty easy. Like let's say you have x going to 2 and you have this weird absolute value. Again, you can just plug in the number and see if you get 0 over 0. In this case, when you plug in 2, looks like you're going to get the absolute value of 4 over 4. Well, the absolute value of 4 is 4 itself, so it looks like you're just going to get 1. So again, just recognize that sometimes you are basically done with the question at the very beginning if you plug in the number and you don't get 0 over 0. Unfortunately, this does not happen very often, so now we're going to do this question. We're going to do first a one-sided limit. So remember that 2 minus, that just means that we're approaching 2 from the left. And we're going to do this limit right here. It's going to be x minus 2 over the absolute value of x minus 2 over x minus 2. So what happens is, again, when you plug in this, you will get 0 over 0, because when you plug in 2 here, you're going to get 0. When you plug in 2 here, you're going to get 0. So this is where we have to do something. But just like with the square root questions, it's not obvious exactly what to do unless you're maybe told to do so or you've already practiced these questions. So basically, again, what you want to do with absolute value questions is just to imagine what side of the absolute value you are on. And how do you determine it? Basically, if you have the absolute value of a positive quantity, the absolute value bars don't do anything. For example, the absolute value of 7 is just 7. If you have an absolute value of a negative quantity, what does the absolute value do? Well, it just negates that negative quantity to make a positive quantity. So for example, the absolute value of negative 8 is negative 8, which is just 8. So what we do is we're going to plug in a number that is a good candidate number, and we'll adjust into the absolute value, and we're going to see if we get a negative quantity or a positive quantity. If we get a positive quantity, we can just erase the absolute value bars because it's not doing anything. If we get a negative quantity, we're going to negate that negative quantity so that we end up with a positive quantity. So let's see how it works in this case. So notice that if we plug in a number left of 2, this is a number like 1.9. What we're going to do again is plug it into the absolute value and see what we get. We don't actually care about the number itself, we just care about whether this is negative or positive. When we plug in 1.9 minus 2, notice that's a negative number. So that means that we're dealing with a negative quantity. So how do we get rid of the negative quantity? What you do is you just change the absolute value bars to parentheses, and then you put a negative in front because we're negating the negative quantity. So in this case, it'll be limit as x goes to 2 minus, then it'll be negative x minus 2 over x minus 2. And notice that after we did our normal do something set, because we had 0 over 0, good things immediately happen. These x minus 2's cancel, so it looks like we're left with the answer of negative 1. So that's again how you do absolute value. You plug in a nice candidate number, in this case because we were 2, going from 2 to the left, from the left, sorry, we took a number a little bit less than 2, like 1.9. And we plugged it in. We didn't actually care about the number, we just care about whether we got a negative or a positive. In this case, it was negative, that's great. All we do is we change the absolute value bars to parentheses and then we negate it. So let's do one more question for absolute value bars, with absolute value bars, to conclude this video. So let's erase this. Let's do the limit as x goes to 3. We'll have x minus 3, and then we'll have 6 minus 2x. So again, first thing to do is just plug in 3 and just see what you get. So in this case, we get 0 over 0. Hopefully you see that because it's 6 minus 6. So now we have to do something. So unlike the previous example, we don't know what side we're on. We don't know if we're on the positive side or the negative side. So when you do this something, unfortunately, you have to split it up into 2 limits. Do what we just did with the negative side and also the positive side. And then what you're going to do is you're going to compare the answers. So let's do that. So it'll be the limit as x goes to 3 minus of this thing right here. And we're going to see what that is, and then we'll ultimately try to see what the other side is. We're doing the 2 one-sided limits so that we can get rid of the absolute value bars. And why are we splitting it up? So that we can have good candidate points, like that 1.9 in the previous example. So it's going to be x3 plus 6 minus 2x over x minus 3. So let's do the left side first. So again, what kind of number am I plugging in? Well, the numbers left to 3 are numbers like 2.9. So when you plug in 2.9, notice that 2 times 2.9 is less than 6. So when you plug in 2.9, you're going to get a positive quantity. So what happens when you get a positive quantity? All you do is you erase the absolute value bars. So in this case, you're going to get 6 minus 2x. Maybe we can write limit here. We can write it on the bottom. 6 minus 2x over x minus 3. And notice this is so much nicer because it doesn't have absolute value bars. And why were we able to get just rid of the absolute value bars? It's because when you plug in any number to the left of the 3, you get a positive quantity. And again, absolute value bars do nothing on the positive quantity. So let's try to simplify this. Again, you need to do something, but the do something did work. We got something simpler. So it looks like we can take out a negative 2 from the numerator. So it's going to be limit as x goes to 3 minus of negative 2 times x minus 3 over x minus 3. Just took out a negative 2. And why is this great? Because the x minus 3's cancel and you're left with a negative 2. So again, how you do this is you plug in a good candidate number. If you get a positive quantity, the absolute value bars go away. If you get a negative quantity, you're going to negate that negative quantity. Finally, just simplify this by taking out a common the GCF, I guess. So in this case, it's negative 2, and these things will cancel, and you'll be left with negative 2. So let's try to do it on the right side. So when you plug in something greater than 3, something like 3.1, notice that 6 minus 2 times 3.1, I don't actually care about what that number is. All I can recognize is that that is negative. So when you get something negative, again, what you do is you just change the absolute value bars to parentheses, and then you negate it. Because again, the absolute value of a negative quantity is negative that negative quantity. So in this case, you're going to get limit as x goes to 3 plus negative 6 minus 2x over x minus 3. Here I'm going to simplify again. So when you simplify, it looks like you're going to get limit as x goes to 3 plus. Basically, I want it to be of the form x plus or minus something so that I can see how these cancel out. Looks like it's going to be 2x minus 6 over x minus 3. If you take out a 2, hopefully you notice that these will cancel and you'll be left with 2. So just be wary that some students think that the left side always gives you the negative quantity and the right side always gives you the positive quantity, but unfortunately that's not correct. You actually have to plug in a number. And if you plug in a number and you get a positive quantity, just erase the absolute value bars. If you get a negative quantity, it's the worst case scenario, but it's not that much worse. You change the absolute value bars to parentheses and then you negate it. Then we got these 2 answers. So we still have to answer our final limit. Remember, our final limit wasn't these 2 in particular. What we need to do is compare these 2 answers to see what this one is. And notice that because we have negative 2 and we have 2, these 2 limits don't match. And remember, if you're going towards different numbers, that means your limit doesn't exist, unfortunately. You can't go towards two numbers, so you're going to no numbers. So in this case, what's the final answer? The final answer is going to be does not exist. And this happens in the majority of absolute value questions when you get 0 over 0 and you have to split it up. But again, absolute value is the trickiest guy, but hopefully you recognize sort of the process. Your instinct is, I do not like absolute value bars. I want to get rid of them as quickly as possible. Unfortunately, if you're going to the number and you don't have one-sided limits, you have to do one-sided limits. But each limit isn't too bad because once you get rid of the absolute value bar by seeing if you have a positive or negative quantity inside the absolute value bar by plugging in an appropriate number, then it's pretty easy things to factor because there will be very simple sort of expressions. And that's how it works. Even in these absolute value questions, it's still the same general strategy from the very beginning of the video. Recognize you get 0 over 0, do something, expand, factor, multiply by conjugates when you have square roots, add and subtract fractions together with common denominator, and finally get rid of absolute value bars by plugging in something and seeing if you have positive or negative quantities. Once you do that, good things should happen, things cancel out, boom, 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 boom. You're gonna plug in the number at the end, and then you'll just get a number. But because this lesson is so important, I understand if you want more practice with this. So what I'm gonna do is I'm gonna link our Girls Teach Calculus video in the description of this video, just like normal, where one of my former students practices a host of these questions. She does a worksheet on these sort of limit questions. She has expand questions, foiling questions, more fraction questions than we talked about, more square root questions that we talked about, and finally she ends with absolute value questions like this, where she's asking the same question that we asked. So we highly encourage you to watch that video. She might explain things a little bit better than me actually, so it should be good practice as you do these limits. But hopefully this video was useful for you. If it was, please give us a like and subscribe. We certainly appreciate that. Hopefully we'll see you in our next video or a video after that. I'm not sure what the next video is, but eventually we're going to be doing these sort of process as we introduce derivatives. So be on the lookout for that. Thanks again for watching, just like normal, and I hope to see you next time. Thanks again.